Okay, students. So now we are going to illustrate or try to understand the relationship between the magnitude of force and the moment of force. So before we go into that, what we will do is, you all know the setup here. We have the board, and to that another board is a plank is attached, and to that you can see a thin plank is attached to it. All these are wooden planks. And then you can see the different points A, B, C and D. And this one is the nut which we are going to use to tighten and increase the magnitude so that we can observe the magnitude of the force that is needed to rotate this plank. And from this will be the axis of rotation, that is the nut here or the screw here, and starting from there. So from the screw to point A, it's going to be 15 centimeters. Then to point B, it's 30 centimeters. C, 45 centimeters. And D, 60 centimeters. So that's how the distance is going to be. First, we are going to understand how the moment of force works. So to do that, what I will do is, I will first attach this is the normal state of the screw. First, we will attach the Newton balance to point A. And as the plank starts to move, slightly move, you will have to get the reading of the Newton balance. So this is where we connect the Newton balance. So here I have marked the lines there so that you can see as the plank moves what the reading is. And we have to have the balance above the board. It shouldn't be touching the board. It has to be above the board. So you all know what to do now. Right, so if I try to pull it, so when I pull, you all can see, students, when it is 2 newtons, the plank just starts to move. So then what we do is we bring it back to the original position. Then I have to move the Newton balance to this nail. We can either use nails or, as shown in the book, we can tie a loop around the plank. We can mark the points A, B, C, D. And then we can place the loop at that point, connect the Newton balance to that and pull as well. So now the distance is 30 centimeters. Again, if I pull, you can see it's at 1 Newton force. The plank is moving. If we try again, when it comes to 1 Newton force, the plank is moving. Then the third one. That's point C, 45 centimeters away. So now here it's 0.6 newtons. I'll repeat again, 0.6 newtons. Then we move it to point D. So here it's 0.4 newtons. If I do it again, repeat again, it's 0.4 newtons. So can you all understand, students? When the point A was used, the force that we needed to apply was 2 newtons. And as we moved away from the axis of rotation, that is the screw, you know the perpendicular distance increases. This is the perpendicular distance. As the perpendicular distance increased, you were able to understand that the magnitude of force decreased. But when we get the multiplication, you will see the magnitude of moment of force will be the same value. Is that clear to you all? But in this activity, we are trying to understand how the moment of force or moment depends on the magnitude of the force applied. So to do that, what do we need to do? We need to tighten the screw. So it was the initial position here, and then you know we have to tighten the screw by half a turn. So I am going to do that. So now it has become tighter. Then we will use 1 point only. So to understand that, I will use 2 different points, the closest point A and the far away point D. So with point A, we will try. Now earlier you all can remember, students, it was 2 Newton force. Now when I try to pull, you can see when I apply a force of 3 newtons, it's starting to move, just about starting to move. So that's 3 Newton. Earlier it was 2 Newtons, now it is 3 Newtons. The same way I will try for point D. You can remember students, earlier at point D it was 0.4 Newton. So now we will try and see. So here we will look at the reading. It's moving when the balance is 0.9 Newtons. So can you all understand the relationship, students? When we tighten the screw, again the amount of force or the magnitude of force that was needed increased at point A as well as point D. So then again I am going to tighten it by another half a turn. Okay, so again I am going to use point A and now we will try to move it and see. So here, so if I try to move it, you all can see when it comes to a reading of 4 newtons, the plank just started to move. So that is the third reading. Initially we had 2 newtons, then we had 3 newtons and now 4 newtons. The same way, if we use point D there, you can remember initially it was 0.4 newtons, then it was 0.9 newtons and now we will try to move it from the same point. Now can you all observe, students? When it comes to about 1.5 Newton, you can see the plank just starts to move. So from these, I am sure you all can understand that when the distance increases, that was not our intention, but you all were able to understand when the perpendicular distance from this point of axis of rotation increases, the magnitude of force decreases. But we wanted to understand that the moment of force depends on the magnitude of the force applied. So at point A, you were able to understand when we tighten the screw by each half turn, the magnitude increased. The same way at point D also. So from this, we can conclude that when the moment of force increases, the magnitude of force that needs to be applied has to be increased when the perpendicular distance is a constant. Okay, students. So now in this activity, we will try to understand the relationship between the moment of force and the perpendicular distance from the point of rotation to the application of force. So as you can see here, this is the screw nail. So that is the point of rotation or axis of rotation. And from there, if we get a certain point where we apply the force, the distance between the two is the perpendicular distance. So here again, I have a plank, a wooden plank that is fixed to the wooden board, and also it has been marked. Now from this point of rotation, point A, the distance is 15 centimeters. A to B, another 15 centimeters. So if you take the distance from the point of rotation, that is the screw nail, it will be 15, 30, 45 and 60 centimeters. So then what do? We have a loop here, that is a twine loop, to which I will be connecting the Newton balance. So when I connect it to this point, it has to be at the 15 centimeter mark, and then I will apply the force, and when I apply the force, we will have to measure the force that is needed to just make the wooden plank to move. So now I have the Newton balance fixed to point A. You can see that, students. I am going to apply the force. So you can see I am increasing the force, and as it comes to 2 newtons, the plank starts to move. So that is the force there. Then what I will do is I will tighten the screw a little bit. That is quarter turn. And then we have to try. Now see, if I apply 2 Newton force, there is no change. So what we do is we move this a little further away, still with 2 Newton, no change. Some more, Now it's moving, so I might have to try a shorter distance as well. Again. I will move it a little bit more. Now you can see when the force is 2 Newton, it's moving. So what we need to do is we need to measure this distance. The distance from the screw nail up to this point. So here students, you all can see it's about 24.5 centimeters. So the distance has increased now. The force is the same, magnitude of force is the same, distance has increased. That is with quarter turn. So again, we have to increase the tightness by another quarter turn. So I have increased the tightness now. From the same point, if I apply 2 Newton force, there is no movement. Bring it to the 30 centimeter mark, still no movement. A little bit more. Now you can see it starts to move. So we will have to just adjust and find the correct point as we did before. So now at this point you can see still not enough. So I'll make it a little further from point B. Now when I apply 2 Newton force, you can see it just starts to move. So this is the distance. So here, if we measure the distance again, it comes to 32 centimeters. Is that clear to you all students? So initially students, we got the reading at point A as 2 Newton force. So that is the magnitude of force. Thereafter we did not change it. So 2 Newtons 15 centimeters. Then we increased the tightness by quarter turn. It became 24.5 centimeters. The same magnitude 2 Newton force. And when we tightened it more, another quarter turn, now you were able to see the reading as 32 centimeters. Still the force is the same. So you can see by tightening the screw, we increase the moment of force. But we have the magnitude of force fixed. Therefore, the perpendicular distance from the axis of rotation to the point of application of the force increases. So, can you all understand the relationship now? Right, students. So, now we are going to do this activity in order to understand couple of forces. So, you are already familiar with moment of force. What is that? There needs to be an axis of rotation or a point of rotation through which you have an axis. So here this screw nut is the point of rotation. So from there, if we take this loop, that is the perpendicular distance between the point of rotation and the application of force. So using that, if I use just 1 Newton balance and apply a force, we will get the reading, and that will be the magnitude of the force that is needed to rotate this wooden plank. So that will be the moment of force. So you know the distance and you can find the moment of force. But we will just concentrate on the magnitude only. So first I will just connect this to this point and I will try to rotate it. As it starts to move, we need to get the reading. So here you can see it's 3 Newtons. As it starts to move, the force is 3 Newtons. So again, if we try also, you will be able to understand it's 3 Newtons. Is that clear, students? Right. So that is by applying one force in a certain direction. Now the same thing, I have 2 hooks here. We will use 2 forces but in the opposite direction. So I'll be pulling this loop towards my side and one of my students will pull using this Newton balance. Student will pull the plank in the opposite direction. So 2 forces will be applied in the opposite directions, and also since it's the same plank, you all know they are going to be coplanar forces. So now we will be applying two forces. Now can you see, when it starts to move, the reading is 1.5 newtons. With 1.5 newtons, the plank is rotating. Can you all understand that? Okay. So that means initially when we used only one force, or when we applied only one force, we had to apply 3 Newton force. Why? The perpendicular distance from the point of rotation to this point was a certain value. But when you have 2 points and the distances are equal, that is another thing that you have to remember, students. The distances from the point of rotation are equal and the forces act in opposite directions, and also they are coplanar forces. Then the magnitude decreases, and this leads to a rotational movement, and that is what we call as couple of forces. Is that clear to you all? So two coplanar forces of equal magnitude acting in opposite direction gives rise to a couple of forces.